So thanks for inviting me. It's been a fun series of email exchanges that we've had over a series of months now, trying to organize this. So today I'm going to frame my talk in comparing risks to wildlife, and I'm narrowing it down to birds, this is my next slide, between the Gulf of Mexico and the Grand Banks in Newfoundland. And so this is the general outline of my talk. So I am narrowing it down to birds. Birds is what I know best. I study colonial water birds. And this is all pictures of various species I've worked on. And if you can identify all these species, you must be a very good birder. So I'm not going to identify them for you. Offshore oil and gas operators really like this graph. And this graph is essentially petroleum discharges to the environment. It's for 1990 to 1999, so doesn't include the last 11 years now, I guess. And so what you can see from this is that you have natural seeps. So there's oil coming up from the bottom of the ocean is contributing to most of the oil discharges in the marine environment. And spills represent a very small amount. However, I'm going to argue today that spills occur, unlike a natural seep, in large batches when they do occur, and they can have disproportionate effects depending on the receiving environment. So just to complicate things, I think we all have an indication of this watching how the spill in the Gulf of Mexico played out this year. It's not a straightforward scenario at what happens to oil when it's spilled into the environment. And so this is a model which you can look at when you have sources of oil entering into the environment, and this is not just spills here. And essentially what I'm going to do is concentrate on the effects of oil on biota, or fauna in this case. But understanding that there's lots of things that are happening. There's water that's moving the oil around. There's weathering, or the breaking down of the oil. And all of this feeds into the impact and whether the oil is going to impact the marine environment, the organisms in the marine environment. So with that in mind, there are three questions we can ask when a spill occurs. Can we contain it? If not, how fast will the oil break down? And if not, where will it go? Right. So in the two oil fields I'm comparing, I'm really focusing on two differences. One is the seabird community, the species that make up that seabird community. And the second is the temperature of the water of the receiving environment, because this ends up being a very important variable in how fast oil will break down. And so in cold waters, oil is slower to break down. And it's for a variety of reasons. That's not my cell phone, that's what I could say. Microbes have trouble grabbing onto the oil. The oil is more viscous. It's available because it's slower to break down. It means it's available to the marine organisms in the environment for longer periods of time than it is in warm water systems. So if you've ever had the opportunity to clean a greasy frying pan with cold water, you inherently know. You don't clean greasy frying pans with cold water. You clean with hot water because the oil breaks down. So if we consider our two systems, I'll just give you a little backup information here. So the Gulf of Mexico, it's a small but deep Gulf, and the continental shelf which is this denoted here, is quite narrow, and it's really on the continental shelf is where you find 99.9% of the organisms that live in the Gulf of Mexico, and where most of the biological productivity occurs. So regarding where most of the oil and gas productivity occurs, you probably can't see it too well, but there are all these little dots here along the coast there, and that's where most of the active platforms are, which is 98%, are in waters of less than 200 meters. So really the majority of the activities that are going on in the Gulf of Mexico for oil and gas extraction are in less than 200 meters, while there's about 7% that are in greater than 1,000 meters. And we have the amounts of oil that were produced within 1 year, oil and gas, for 1 year. But there is a move to drilling further offshore, because essentially they're tapping out all the sources that are available on the continental shelf. So if we look to Newfoundland, the continental shelf is big. The Grand Banks is part of the continental shelf. The continental shelf is denoted by these contour lines going along here. And there's a lot going on to this graph, or this figure. I've denoted 3 offshore production platforms, all oil, no gas, White Rose, Hibernia, and Terra Nova. And what you'll note from the scale is that they're 350 kilometers or further offshore. So they're not close to land, unlike what is going on in the Gulf of Mexico, which is mostly close to land. I've also denoted the Orphan Basin, which was a point of contention when the Gulf of Mexico spill was going on, because the Orphan Basin Chevron had a permit to go drill in waters twice as deep as the Deepwater Horizon spill. And so there was a bit of debate as to whether we should allow them to go ahead and drill this very deep well while there was this incident going on in the Gulf of Mexico. And then I've also flagged Old Harry. And Old Harry, I hope we'll all hear about on the news more and more. It's a well that has not been explored, it hasn't been drilled yet for exploration. But through seismic testing, they're estimating that Old Harry has 2 billion barrels of oil, which is going to be bigger than Hibernia. And it lies right on the border of Quebec and Newfoundland, in the Gulf of St. Lawrence. Needless to say, this has made the fishing communities of the Magdalen Islands and various coastal communities in the Gulf of St. Lawrence extremely concerned about the ramp up of oil and gas exploration in Newfoundland. And in fact, they're parcels that have been open for bid to oil and gas companies literally right up to the coastline in western Newfoundland, including next to Grossmoor National Park. So the oil production in comparison was relatively small to the Gulf of Mexico. In 2007, there was 134 million barrels of oil that were produced. And by 2009, there was the mark of 1 billionth barrel of oil that was produced from this region. And there's a bit of gas exploration going on in Nova Scotia, but I'm not going to deal with that any further. So if we compare our 2 oil fields, this is a picture of sea surface temperatures, likely for late spring, where darker blue is cold waters and the redder is warmer waters. So what you can see is that the average temperature for the Gulf of Mexico is in the mid-20s or higher, and for the Grand Banks is quite cold. It's between 10 and 12 degrees Celsius. So if you're then going to consider the biological effects of a spill, I'm going to break it down and think of these 3 questions. So where is the oil going? What organisms should be monitored? And at what level should you be asking whether there's impacts? So if we consider where, in the Gulf of Mexico for the Deepwater Horizon spill, essentially it was going both onshore and offshore. And it was and because of this, it was hitting the coast, and coastal birds were being affected, and not just marine-based organisms, but freshwater-based organisms. And then you also had it moving offshore, where more of the pelagic or ocean-based organisms, birds in particular, were living. The Terra Nova platform, which was run by Petro-Canada at the time, now it's taken over by Suncor, had a spill which was not that well covered in 2004 that spilled 1,000 barrels. So remember, Terra Nova platform's 350 kilometers offshore. So this spill never made it to land. It essentially just kind of moved offshore and eventually broke down. There's some visuals here where you could see the spill from a satellite imagery, and it was estimated that less than 5% of the spill was recovered, and the spill size at one point was 10 kilometers long and about 2 kilometers wide at either side. So you have a spill, you hopefully know where it is, and where it's going, and you're doing some attempts to contain the spill. I've narrowed this down to seabirds. So what organisms should be monitored? One group of organisms that should be monitored would be species of conservation concern. Why? Because we already know their populations are stressed. They have low numbers. For whatever reasons, they have low numbers. And so you want to know that, in fact, this event isn't going to just put them over the edge. And really, when I thought about the Gulf of Mexico spill, I didn't think about seabirds. I thought about sea turtles, because there's 5 groups of species there that are all critically endangered organisms. And this is kind of yet another effect on those populations. So we have legal obligations under the Migratory Bird Convention Act to deal with seabirds that are affected by oil. And we also have in Canada the Species at Risk Act to deal with species at risk that might be affected by various oil spills. So in the Gulf of Mexico, if we look at the seabird communities, and this includes, I'm using seabird kind of liberally here because I'm also considering coastal birds as well. But in the Gulf of Mexico, there's about 40 species, some 16 million birds, and 8 of which you would deem highly vulnerable to oil pollution. So if they get oiled, they're likely to die even from small amounts of oil. And I just have a couple of species listed here. And there are some, it's mostly diving birds that are very vulnerable to oil, where they're living on the water. In the Grand Banks, there's some 39 species of birds that either breed there or overwinter there. There's large numbers, millions of auks, murres, and dovekies, which move down from the Arctic, from Greenland and from Arctic Canada into the Grand Banks to live for the winter. So some 20 to 60 million seabirds. You can see I have no confidence intervals on these numbers, and I'm going to talk about that in a minute. And some 16 species are highly vulnerable to oil pollution. And in this way, it's likened, so remember, these birds are living on the water, so these are what you consider, if you're approaching these birds on a boat, they would be more likely to dive than they would fly. So they're really living at the air-sea surface interface, and they're sitting on water that's 10 degrees Celsius. So 10 or 12 degrees Celsius. And so consequently, they don't have fat like marine mammals do. They have this incredibly dense plumage that protects them from these cold temperatures. So you get a tiny drop of oil on a bird, and it's been estimated less than 10 milligrams, which is the size of a dime of oil on a bird, and it can kill it through hypothermia. So it's like a hole in the wetsuit phenomenon. So cold water is allowed to seep in to the plumage, and essentially the bird dies of hypothermia. And this is well established. Environment Canada knows that chronic oil pollution is a significant problem to seabird communities on the Grand Banks. And in fact, it's been estimated that annually, some 200 to 300,000 birds a year are killed from chronic oil pollution, mostly due to ship-sourced oil pollution. And that's the estimate that was given for the Exxon Valdez oil spill. So small amounts of oil are a big problem in this system. So you have a spill, and then biologically you want to ask questions like, what is the effect of the spill? We could look at individual behavior, so are individuals behaving differently because they've been exposed to oil. But from a biological point of view, what you want to do is ask the question, is the population damaged? Can the population persist through time? Because if it was so significantly damaged, then it's a problem. And so really the questions that you want to address are at the population level. And seabirds lend themselves to doing various population works because they come to land every year and lay eggs and stuff. But it's only the breeders that come to land, and it's a bit of a more complicated question. So we have some idea of population sizes for some species, but it's actually a much harder question than you might think. So John Weens is a very well-respected seabird biologist, and he's done a lot of work on modeling of oil impacts on seabird communities. And so this is a flow chart that he's created where you essentially have an oil spill. And you can have the effect of initial oiling, which results in there was essentially no effect, or that you did actually have direct mortality. And by having direct mortality, you could have decrease in population size. It could have been the spill killed more females than males. It could have been the spill killed breeding adults or non-breeding adults. So it could change the population size, structure, and that could have other implications such as reduced reproductive success or that birds leave the area and immigrate out of the area. You could also have secondary release of oil, and this is what we're seeing in the Exxon Valdez area, where certain species, because of how they behave, go down, dig up stuff from the sediment, and releases oil. And that exposes them continually to hydrocarbons. And so then you have this series of effects, potential effects from secondary releases of oil. And then we have the effects from cleanup activities, which also was an issue from Exxon Valdez spill, and as we're seeing likely from the Deepwater Horizon spill with all the dispersants that were used. So to ask the question, was a population significantly damaged in an oil spill, is a challenging one, and it involves a lot of different variables. And the biggest take-home message that John Ween has had is do not assume there's an effect until you measure one, until you can actually measure one. So how would we do this? And I just have this one slide here from the Exxon Valdez because this spill divided the seabird community, and I could have given a whole lecture on why that is. And essentially what we had was the number of murs that were killed in the spill. So we have a body count. That's the only fact that we have. We have a body count and we have the amount of oil that was spilled and some activities about how it was cleaned up. But what we know from other studies is that 21,000 birds that were collected that we know died only represented between 10 and 30% of the birds that were actually killed. So then there was an extrapolated estimate that somewhere between 100,000 and 300,000 birds were killed from the Exxon Valdez spill. It wasn't this that we were disagreeing with. What was the disagreement was whether this 100,000 or 300,000 birds that were killed was a significant impact to the population before the spill. And one of the issues was that we had not very good data on these populations prior to the Exxon Valdez oil spill. So if we go back to the Gulf of Mexico and then consider some challenges in studying populations in the context of oil spills, there's a bunch of birds that are migrating through the area. And these numbers don't even consider little dicky birds. There's about 1 million birds that are nesting there, and about 15 million ducks and geese that overwinter there, both on the coast and in the coast. And I note here the roseate tern, which is a species at risk, which migrates down to the Gulf of Mexico every winter. So it's a concern that a lot of the species that were moving down from Canada would be exposed to oil pollution and suffer. So let's consider a specific example. I have here a graph that was, you can go onto the United States Geological Survey and come up with these types of data. And these are all the colonies that they know of for brown pelicans along the Gulf of Mexico. And the larger the circle, the larger the colony. And very importantly, they've aged the data. So the red is after 1995, and the gray, the darker shade of gray, is before 1975. And this age of data has implications, because if you're, say you're a lawyer and you're sticking up for the seabird community, right, and you tell BP that there are all these colonies here that were affected, but those colonies hadn't been surveyed since 1975, you're probably not going to get too far in court in demonstrating an impact. So these are data which overlay the colony with the Deepwater Horizon spill. And what you can see is likely there were some brown pelicans that were affected by this spill. But it's unlikely, due to the age of the data, that we will be able to demonstrate an effect on the particular population. And this is a very well-studied species because it was endangered. If we go to Newfoundland and consider some numbers, Funk Island, which used to be home to the endangered extinct great auk, has some 800,000 birds. Leach's storm petrels, Baccalieu Island, the largest colony of Leach's storm petrels in the world, has some 6 million birds. But these counts haven't been done since the mid-'80s. And not only have the counts been done since the mid-'80s, there's no confidence intervals around these numbers, because in order to get error around a number, around a mean, you have to go out and measure it more than once, right? So we also have summer migrants, which are birds that breed in the South Atlantic Ocean and migrate up to the Grand Banks. And then we have these winter residents that I talked about that migrate down from the Arctic on the orders of 5, 6, 7 million birds, right? So the problem is that you have large densities of birds and not very good counts of these birds. And not only challenges at the colony level, there's not investment in going to these colonies and doing a lot of sampling and understanding the population sizes, but the variation at sea for their densities and abundance is also quite high. So this is data from 1994 that were compiled in 1994, so they were earlier than that, from the 70s to the mid-90s. And the purple shows high densities of seabirds, which is 100 to 400 per square kilometer. And then there's squares where there's no seabirds. So what you can see is there's a lot of variation in the distribution of these different species through space and through time. So if you were then going to ask, was a population affected? This is a hypothetical graph, again by John Waynes, where you have time along the x-axis and population size along the y-axis. And so here you have a population that's going through time. And what we know about marine populations in particular is they vary a lot annually for a whole bunch of different reasons. Water temperature or food availability or whatever, they're going up and down. And so you have this perturbation then on the system. How do you know whether a population was affected, right? So in this case, the population, these dotted lines here are 95% confidence intervals around the mean. So we know a spill happened here and the population dropped outside of the confidence intervals around that. And then we would deem that the population recovered when it entered back in around the confidence intervals around the mean. On the B, you have a population that's already declining for other reasons. Again, you have the perturbation, the population drops, it recovers in the 95% confidence intervals, but at a much lower number. So theoretically, operationally, the impact would mean when the system's displaced outside of these confidence intervals, and recovery would be when it enters into it. But you need data to get there. So if we consider the Deepwater Horizon blowout, 4.9 million barrels spilled, over 1,000 kilometers of coastline oiled, and at the height of the spill, there was some 25,000 kilometers squared of oil available to kill things, right? And then the immediate impacts, and these are numbers from the USGS website in November of 2010. So there were 8,100 birds retrieved, and of those, 6,100 died. And remember the estimate of direct mortality is that 8,100 represents some 10 to 30% of what was actually killed. So what was actually killed is somewhere between 27,000 and 81,000 birds, except nobody's actually done that extrapolation, except for me, which I guess I'm going on the record for, but it's not a hard and fast, it's a hard and fast one, not a written word. So the species that were most impacted, brown pelicans, northern gannets, and royal terns, all of which are diving diving species. So if we go back to the Terra oil spill in 2004, they only spilled 1,000 barrels of oil. That's like a relatively small spill on the industry scale of things. The spill went on for 24 hours before it was caught. Essentially, their produced water system stopped filtering oil, and they were just dumping crude right straight into the ocean for 24 hours. And there were no dead birds collected. And that was primarily because the Environment Canada biologists weren't on the scene until 5 days after the spill, which you can ask me about in our discussion why that might be. And the Coast Guard, in fact, never showed up to this spill. But the Environment Canada was able to do some estimates of what the mortality was for this spill, and it was somewhere between 10,000 and 16,000 birds for a spill that was only 700 square kilometers. So proportionally, much smaller spill, but had a significant higher number of direct mortality. And one of the reasons why chronic oil pollution, these small spills, barrel here, barrel there, 5 barrels here, 10 barrels there, which is going on the offshore system all the time on the Grand Banks, is that these data, which is the volume of spill on the x-axis and the number of birds oiled on the y-axis, if you eyeball it, you might think it's a significant and positive correlation, but in fact, if you run the numbers, it's not. And what that means is that large spills don't necessarily mean large numbers of birds are going to be killed, right? So it's not, these are not significantly correlated. So it means that you can have a small spill that can kill lots of birds. But in Newfoundland, depending on the time of year, a large spill will almost certainly kill more birds than what has seen in the Gulf of Mexico. So to wrap it up, when we were talking about the title of this talk, can an oil spill like the BP Deepwater Horizon one happen here? In my mind, I would argue, in fact, it already has. When we look at the mortality of seabirds due to chronic oil pollution in Newfoundland. But there's a problem. So there's some 400, between 1997 and 2009, there's some 417 spills that have happened and over 400,000 liters of hydrocarbons and synthetic hydrocarbons. But this is the problem, right? So the problem is getting the data to actually do that type of analysis. And I'm in the process actually I've submitted a whole bunch of Freedom of Information requests in the past around oil pollution. And I'm now in the process of submitting some more where I'm essentially asking what the response was of the operator, the oil and gas companies, to small spills. So did they go out and try and contain it? Did they go out and have a biologist on site that counted the number of birds that were oiled? Because these data are not on the regulator's website. Right? They exist somewhere, or that they didn't respond to the spill at all. And these are very important questions to be understanding what is the impact of oil and gas on avian wildlife in Canada. And I just want to wrap it up by saying oil spills come with visually disturbing imagery, right? Media loves to feed us that. And it's really our obligations to both understand and address the immediate impacts, and it has ethical and legal and ecological implications. So ethically, we have to care for the organisms that were oiled and try and keep them alive and return them to the wild. Legally, we have a whole bunch of different types of acts, like the Migratory Bird Convention Act, and also that it's just outright illegal to spill oil in the marine environment. And ecologically, I think it's important that people step back and not assume that large spills will have a significant impact on marine populations, and that we need to make sure that we have the data in place to answer those questions. And it's an important one here, and I have a picture of the Arctic and some thick-billed murres here. This is one of the longest running projects of monitoring thick-billed murre populations in the Arctic. It's been going on for 30 years. And these types of studies are critical to our understanding of what anthropogenic impacts like oil spills are on these populations. And in the Environmental Monitoring Assessment Network, which observes changes in ecosystems over time, lost 80% of its budget. The Migratory Bird Program, which monitors the health of bird populations, has seen its budgets cut by 50%. And there's been significant slashes to these programs, which are going to be the basis of which we determine the impacts of oil spills on these populations. If we don't have the data, if we don't have the baseline data going into these oil spills, we won't understand what's happening. So, thank you.